Question 3.3 also has to do with finding midpoints. And just like with distance, we'll be looking at two scenarios, a midpoint on a number line and a midpoint on a coordinate plane. And so the simpler one is on a number line, so that's what we'll start with here. Okay, regardless of how we're applying the midpoint, it means the same thing. It's the point on a segment that is equidistant from its two endpoints. So if you have a segment, we'll call it AB, and point M is the midpoint of that segment, M is going to cut that segment into two equal parts, where those distances AM and MB are equal. Okay, so if I ever needed to write that expression, the reasoning for it would be by definition of bisect. Okay, so we can use this in our proofs by identifying a definition that will equate those measures as being equal. All right, so let's look again at whether it's on a number line or a coordinate plane, this relationship holds true. So the easiest or the simplest form first is just a number line. Okay. The midpoint on a number line is simply the average of the coordinates. Okay. So if you are given a segment AB, which we don't necessarily have to draw it in here, but I will just to illustrate, with coordinates A and B, the midpoint is going to be located right in between them based on the definition. And the coordinate of this midpoint is just the average of A and B. And the average is found by adding them, dividing by the number that are being averaged. So just A plus B divided by 2. Okay, so there's a couple different ways that you'll solve this. One, just the real straightforward way, is if you're given coordinates. So let's say we look at this first example problem. If you want to find the midpoint of x, y, and so once again, I'll sketch it just to illustrate. If the coordinate for x is -5 and the coordinate for y is 18, and you want to find its midpoint, so I'll call that M. Well, that midpoint is going to be the average of its endpoint coordinates. So if we just take -5 plus 18 divide by 2, that's going to give us the coordinates for this. -5 plus 18 nets a 13 over 2. And so that's going to be your answer, 13 halves. And you can also write it in the decimal form, 6.5. Okay, but either form, rational or decimal, is fine, but you're just taking the average of their coordinates, and that's your midpoint. Okay, now, you may also not be given specific coordinates for the endpoints or midpoint. You might actually be given expressions in the problem. Okay, we're still going to base it on the fact that the midpoint cuts a segment into two equal parts. So another type of example that you might see would be like this second problem. What's the measure of PR here if Q is the midpoint of that segment PR? Okay, so here, if Q is the midpoint, then we know that PQ and QR have to be equal to each other. So what expression can we apply to PQ? Olivia? Okay, so we could either say it's 1/2 of 14x plus 2. So if that's the case, then what is the actual expression for PQ? 7x plus 1. So if we're doing it this way, the way that we would solve this problem is we would now say that we know that Q is the midpoint, therefore PQ and QR have to be equal. That's by definition of bisect. And what expression were we given for QR? QR was given as 6 minus 3x. And PQ we expressed in terms of this whole PR as being half of that. So it's the expression 7x plus 1. So what we could do, if we set it up in this form, is we could now solve for x. We're going to add a 3x to both sides. It's going to net us 10x on the left. We can move our constants over. Is equal to 5. Divide both sides by 10 to isolate your x completely. Oops, I'll write it here. The 10's cancel. 5 over 10 reduces to 1/2. So we get x is equal to 1/2. So if x is equal to 1/2 and we want to solve for PR, which of these expressions do we plug 1/2 back into? So this is PR. So if we take 14, plug in the 1/2 for x, and solve, we get half of 14 is 7, plus 2 is 9. So here's one possible way we can approach this. Okay. The other possible way that we can approach this is, again, just to use the concept of segment addition. If we know that QR and PQ are equal, we can express PQ in terms of the same expression, 6 minus 3x. And so we can use segment addition here to say that the sum of the parts, 6 minus 3x plus a 6 minus 3x, has to equal the whole, which was given as the expression 14x plus 2. So this is just segment addition. Again, if we were to justify our steps. And then we just combine our terms. So here, if we combine our like terms, we get 12 minus 6x equals 14x plus 2. Move all the x's to one side of our equation. So if we move the x's to the right and our constants to the left, we'll get a 10 is equal to 20x. Divide both sides by 20. Solve for x. We still get x to be 1/2. And we'd still plug it into the same place as before. So